Okay, so in this short clip, we're just going further into detail about how we're going to figure out those x-intercepts from our factored form. So if you watched the previous video, we moved from vertex to standard to factored. What happens at that last step is you're trying to figure out what your two x-intercepts are. Heads up, there could be two, there could be one, or there could be none. Okay, so you could have a graph sitting above the x-axis. It could go through twice, which is pretty well typical for a lot of functions, or it can simply sit right on the x-axis where it only has one. Your process is always to set brackets equal to 0. Okay, so you're just going to, again, focus on setting your brackets equal to 0. For number 1 here, y equals x minus 4, x plus 8, you just simply take the bracket, set it equal to 0, and same thing on the right-hand side. If it's easier for you to think, just flip the sign on the number, you could do that. It will always have x isolated, just like this. Picture it as a one-step equation. So you have x minus 4 equals 0. If you want to get x by itself, you're going to do opposite operations of adding 4 to both sides. Okay, algebra that you would have explored the last couple of years. Negative 4 plus 4 equals 0. And that will give you your first x-intercept. Okay, a positive 4. So take a second, try it on the other side. Okay, you can even pause if you want to. So we have x plus 8 equals 0. My opposite operation of adding by 8 is subtracting by 8. I'm going to show that on both sides to make sure that all of my equations are holding equality, that they're equal. Plus 8 minus 8 cancels it out. And you're left with your second x-intercept, which is negative 8. So if we were asked communication questions about this particular expression or equation, it has two x-intercepts at 4, negative 8. X-intercepts happen when y equals 0. So if we were to put it into a coordinate pair, it would be 4, 0, and negative 8 and 0. Okay. If you plug those numbers in, what it would do, it would zero out the whole equation. So 4 minus 4 in the first bracket equal to 0. Boom, everything cancels out. You might also run into contact with a case like this. So notice how similar it is with the brackets. The only difference is you have a number in front. We're going to actually just follow the exact same process as the other side. We're just going to disregard that number. So this has already been factored. You don't need to do anything further on your part. So once it's been factored like this, you're just going to, again, set each bracket equal to 0. So I have x minus 1 equals 0 on the left side. I'm just going to add 1 to both sides. And I get my equation, or sorry, my first x-intercept. It's just going to be positive 1. Same thing here. I'm going to subtract by 4. And you get negative 4. Okay, so again, two x-intercepts. If we want to put into a coordinate pair, x, y, x equals 1, y equals 0. Same thing over here for x2. It's negative 4 and 0. Okay. Let's pop a third case in just for fun. So what if you have something that looks like this? Okay, because this is something you might run into on the quiz. So you have x minus 2, x minus 2. If you have the same bracket twice, only solve one of the brackets. What this means is you only have one x-intercept, which we're going to graph out in 1 second. So I'm just going to solve this bracket once because I'm going to get the same value either way. So using my same opposite operations rules, I'm going to add 2 to both sides, cancels out on the left side, and I get down to x1 is equal to 2. Now, if we solve that second bracket, which I'm just going to underline in purple, you would get the exact same answer, right? So x2 would also be 2. But again, when we have repeated brackets, you're going to only solve one. Okay, what does this look like, right? So if I were to draw out a plane, a little bit of a Cartesian plane, so this is x, and this is y. Obviously a rough sketch. Let's say this is 0 right here, the origin. This is 1, this is 2. That means that there's only one x-intercept, which is at x equals 2 right here. And I'll just use a different color just so you can see it better. It is going upwards. So, whoops. It looks something like this. So notice that it's sitting, right on the x-axis right here. So this would be a case where you just have one x-intercept. Okay, hopefully that makes sense. Obviously the other ones with 2, it's going to go right through, right, the grid, and you can use Desmos to support yourself. But if you just have one, it's going to be, again, just sitting on the x-axis, whether it be the direction of opening is up or down.